Okay, we talked about a lot of little details yesterday, and so we're going to put all that together today. So far, when you've done a linear model, you've been given the means and standard deviations of the two variables, right? If you're instead given a list of the data, so in this case we have a list right here on the screen, then you're not going to have to go through and find the means and standard deviations, et cetera, et cetera. Like, you can skip that step, all right? Your calculator can give you a model, okay? So here it says classified ads in the Ithaca Journal offered several used Toyota Corollas for sale. Listed below are the ages of the cars and the advertised prices. And then it says we're going to make a scatter plot, describe the association, and yada yada. We're going to answer these questions. So we need to go ahead and put the data in our calculators, and we can make a scatter plot and start talking about it. And then we can answer all these other questions. This is in the chapter 8 exercises, so page like 192-ish. It's number 41. That's number 41 in those exercises. This takes me a lot longer up here, I apologize. There's 15 values in each list. Once you put it in your calculator, go ahead and make a scatter plot. Age is your explanatory variable. And hopefully your scatter plot looks something like that. Make a scatter plot. So after put your data in, make a scatter plot. Everyone has data in and all that. Okay. Again, it's number 41 on page 197, so you guys can find that stuff too. You hit second stat plot, sorry. I know. Hit enter, then you would go, and L2 is second 2. And then always zoom 9. All right, if you don't have the data, you can go to your textbook. It's number 41 on page 197. All right. Making a scatter plot, we did that. On B, describe the association. So how would you describe the association between age and price? Negative, linear. That's pretty strong. Right? They're not very spread out. Right? So we would say that there is a strong negative linear association between age and price. You guys could do that. We've done it before. All right. Part C. Do you think a linear model is appropriate? We talked about how to answer that question yesterday. How do you answer that question? The residuals plot, right? If you're going to say if something's appropriate, you look at the residuals plot. We want to make sure there's nothing underlying happening. Remember, if you're going to fill in the residuals, you need to do a regression analysis first. So we need to go to Stat Calc 8. List 1, List 2, calculate. We just need to do that in the background so that it makes sure that it has the right information. Now if you go to your lists, your residuals list should already be there because you put there yesterday, but now it has the correct value. Okay, so yesterday it should have like a 12 to begin with. Now it has the correct values. So it has all of the residuals. So if we're going to look at a residuals plot, we'll go back to your scatter plot and change the Y list to residuals, so RESID. Not original. Everyone did that yesterday. Zoom 9. So there's our residuals plot. Yes, we just do X. It doesn't matter actually. You can do X versus the residuals or the Y versus the residuals. You're just making sure there's no pattern. There's just one point up there. I mean, I don't see like a distinct U shape. So if you're looking at this residuals plot, you can see some points above, some points below. There's not any like distinct pattern. Would you agree? So is the model appropriate? Yes. Yes. So we would just say the linear model is appropriate, and we would say because a residuals plot shows no real pattern. You want to say why and then how you got to that answer. Questions about C? Okay. Right, there's no pattern in the residuals plot. All right, computer software says that R squared equals 94.4%. That's also in your calculator. If you go back to Stat Calc 8, we'll look at that again in a second. All right, but it says 94.4%. What is the correlation between age and price? Well, you have two options. One option is it's in your calculator, right? You already know how to find R. Second option, in case you weren't given the data, all right, so let's say they just tell you R squared, 94.4. Then you can find R by taking the square root of 0.944. That will also give you R. What's the one thing you need to do if you're doing it by hand this way? You need to make sure you know the sign. We already looked at the scatter plot. We know it's negative, right? So we would make that negative whenever we took the square root, right? So we could do it that way. Square root of 0.944. So negative 0.9716. Or again, go to Stat Calc 8. You already know how to find R. You already have the data in your calculator. And it says negative 0.9718, so we're close. So there's two ways to find R. Questions about that? A lot of the time, they are going to give you not the data and just give you R squared and ask you what R is. So you need to make sure you know both ways. All right. Questions about D? All right. Explain the meaning of R squared in this context. That's that sentence that you have to memorize that we talked about yesterday. Talking about the percent of the variation that's accounted for. Yeah, that one. So we say 94.4% of the variation of what was the next part? Y. So Y is price. So variation of price or variation in price is accounted for by whatever X is, so age. That's a lot of the variation, right? It means our line has the points are pretty tight around our linear model about our line. And so that means there's only about 6% that's unaccounted for by these two variables, by maybe something else. Right? So that's pretty strong. Right? This is a pretty good fit. So if they ask you, sometimes they'll ask you, so does the model fit well? Well, 94.4% it fits really well. Okay? Questions about E? All right, F. Why doesn't this model explain 100% of the variability in the price of a used Corolla? What would have to happen for it to be 100%? R would have to be 1. And is that going to happen if you're looking at used cars for sale in a newspaper? No, right? That's going to be based on mostly what the owner wants to sell things for, right? There's not going to be some direct formula where everything is going to line up perfectly, right? So there's going to be some owner just decision making and making a price, right? There's not going to be some exact science to it. Does that make sense? Mm-hmm. We said that. We said there was 2 ways to do it. If you aren't given the data though. So in some of the homework tonight, you're not going to be given any of the data. Right. So you just need to make sure you know that they're related. R squared and R are related. All right. Any questions on that first part of this question? We did all of that pretty much either last night or yesterday in class or the day before, right? All right. This next part though, still the same information. Use the advertised prices for Toyota Corollas given in exercise 41 to create a linear model for the relationship between a car's age and its price. So A says find the equation of the regression line. So again, we don't have the means and standard deviations given to us, right? We could find them all. Like I could find the mean and standard deviation of one variable, right? List 1, just do stat calc 1 variable statistics. And I could do it again for the second variable for the second list. That's a lot of extra work though when your calculator will do it for you. So we keep going to stat calc 8. So it's on my screen, but just if you want to go back, stat calc, just you can click number 8. You don't have to scroll down. List 1, list 2, and it gives you an equation. So this is telling you y equals a plus bx. That is what we have the form of our model in this class. We have y hat equals the intercept plus the slope times x, right? So that is the correct format. So that means a is the y-intercept, and b is the slope. It tells you at the very top of the screen what is what, right? It tells you what order everything goes in. So all we have to do is write this down in context. Okay, so what is our y variable? What is our y variable? Price or age? Price. So we have price hat equals our y-intercept is 14,285.95, right? Then it would be plus, what slope is negative, so we can just do minus 959.05 times h. There's your model, right? Now, again, if you're not given the actual data, you can't do it. It's not that easy, right? You have to go through the formulas. But if you're given the data, you can use your calculator. And that's completely acceptable to do. Any questions about where that came from? Could you do that again on your own? So that's just, you're going to have to decide when you make your scatter plot, because you probably have to look at the scatter plot first. So you have to make sure you decide, well, what's causing the other. So you would think that age, the older a car gets, probably the less it's going to be asked, like the price is going to be asked for. All right, any questions about that, part A? All right, part B, explain the meaning of the slope of the line. So we talked about this a few days ago. We're going to interpret the slope. What do you need to say? For every 1x. So for every 1 year, right, age, for every 1 year, the price decreases by $959. Does that make sense? That's how you interpret slope in context. Explain the meaning of the y-intercept of the line. So y-intercept occur where x equals what? 0. So at 0 years old, so brand new car, right? Brand new car, we would expect the price to be $14,285. Does that actually make sense? That one makes decent sense, right? It's not completely nonsensical. For a brand new car, $14,000, right? That's not like some random number, right? That could be feasible. We're talking about Toyota Corollas here, right? That could be feasible. We could see that happen. If you want to sell a 7-year-old Corolla, what price seems appropriate? So how would I figure that out? Just put 7 into the model for age, right? You could do that. I'm trying not to waste your time, so you have time to do work in class today. You have a chance to buy one of 2 cars. They are about the same age and appear to be in equally good condition. Would you rather buy the one with a positive residual or the one with a negative residual? And explain. So how do I find a residual? Actual minus predicted. So if you have a positive residual, which price is larger, actual or predicted? Actual. So positive, the actual is more. And if you have a negative residual, which one's more? Predicted is more. So would you rather buy the one with a positive residual or a negative residual? Negative, because that means the predicted price is more than what you're actually going to pay for. All right, so that's a nice surprise for you. Okay. F, you see a for sale sign on a 10-year-old Corolla stating the asking price is $3,500. What is the residual? So how would I calculate that? What would I have to do to get that answer? That's the actual price. So how would I find the predicted price? Just plug it in, right? And then I could do actual minus predicted to get the residual.
What do you mean?
Residual, remember, is actual minus predicted. So $3,500 is the actual price for this 10-year-old Corolla. So you take $3,500 and put it in, or sorry, 10 years old, because we're using age as X. So we put 10-year-old into the equation, and so then we get a predicted price. And so we could do $3,500 minus whatever we got. And then G, would this regression model be useful in establishing a fair price for a 20-year-old car? See some people shaking their heads no. Why is the answer no? Right, our data set shows ages of 1 to 13 years old, right? So 20 years old would be an extrapolation. We talked about that a little bit yesterday. We don't know what happens after 13 years old. So in our model, in our scatter plot, everything was linear, but maybe after 13 years old, it's not. I don't know. I don't have any frame of reference, so I don't want to make a prediction about something I'm not really sure about. Questions on any of those things? All right, I want to show you one more thing you can do in your calculator really quickly, and then I'll let you do the assignment. So everyone's clear about where the model came from and all that, and that's great. If you go to StatCalc 8, though, there is this place right here. It says Store Regression Equation. I can store the equation in y equals, and it'll graph the line on the scatter plot if you want to do that. You don't have to do that, but if you wanted to see the picture, all right, make sure everything matches up. If you go to, I'm going to get this wrong, alpha, alpha trace. If you have an 83, I can show you this later. If your calculator's not updated, it won't do this. But if you let me update it, I will, but it will. Hit alpha trace, and it gives you a y variables menu. That's just the equations that you'd get when you hit y equals. So I'm just going to put it in y1. And then I'll hit calculate, yada, yada. But now if I go to y equals, it has that equation stored. My scatter plot is on residual, so I'm going to change it back to list 2. All right, so now I'm going to have the scatter plot, and the line will be graphed on top. Yeah. Zoom 9. So now the scatter plot and the line. Is that very helpful to you all the time? Not really, but if you wanted to see it, make sure that maybe your residuals plot ends up having a bend in it or something, and you want to go back and look, then you can look and see, oh, maybe there was a curve in my data I didn't really realize or something. Okay. So earlier when you said you thought there might have been a bend in the residuals plot, you can see right here that there are a lot more points underneath the line right here than there are over the line, right? But over here, they're over the line. So that's why you might have seen this slight, maybe itty-bitty little teeny curve. All right, questions on any things we talked about today? Pretty much all of the things we've been talking about the past few days put together.